Hi, everybody. It's Professor Mitchell, and we're starting today with Chapter 1, Introduction to Statistics. Now, this section has, or this chapter really has a lot of vocabulary. Some of it I'll go through kind of fast. Others, I'll slow down and spend a little bit more time. This chapter has 3 sections, and you can see them right here. So we're going to start with 1.1, which is Statistical and Critical Thinking. And you'll see the next 2 sections in the next 2 videos. All right, so the key concept behind this section really talks about the process of doing statistics. As you're going to see on, I think it's the next slide, statistics is a lot more than just crunching numbers, all right? So if you're feeling nervous about statistics because, oh, I'm not a math person, that's not, I mean, that's part of it, but that's not even really the most important part of it, okay? Prepare, analyze, and conclude. So the analyze is usually where the number crunching happens. And if I had it my way, everybody would have easy access to technology and we wouldn't even spend a whole lot of time talking about how to do the number crunching, okay? We will spend some time on that though. Okay. Oh, it's actually on this slide. See that? Statistical thinking involves critical thinking and the ability to make sense of results. So one of the things that I really like about the textbook that this course is based on, that I'm using these PowerPoints from, is that he asks a lot, by he, I mean the author, he asks a lot of really good critical thinking questions, okay? Statistical thinking demands so much more than the ability to execute complicated calculations. That is so true. All right, so you're going to hear us talking a lot about data. When we talk about data, I think most people, when they hear data, picture like big sets of numbers. And yes, that can be data, but it doesn't even have to be numbers. All right, if you're doing a study on Merced College students, one of the things that you might want to know is what are the genders of the students involved? Are they freshmen or sophomores? Where are they from? So any of those things can be considered data, okay? Any sort of interesting aspects of the things that you're studying, okay? And then every single statistics book that I've ever taught out of, and there have been a few of them, has their own way of defining statistics, and I like this way. The science of planning studies and experiments, obtaining data, and organizing, summarizing, presenting, analyzing, and interpreting. So there's a lot that goes into statistics, okay? All right, continuing with the vocabulary, we're going to talk about a population versus a sample. That is a super important thing in statistics. So when you're talking about a population, you're talking about everybody or everything that you're studying. Okay, so good example, all Merced College students would be a population. All right, I'm trying to draw some kind of conclusion about Merced College students. For example, Merced College students who use the Student Success and Tutorial Center do better than those who don't use it, okay? So that's a statement about the population. Now and they do have ways of figuring that out, all right? But Merced College is a pretty big population. So what I might do to try to make that conclusion, I'm just going to skip down here to where it says sample, is talk to a sample of students who use the Student Success and Tutorial Center versus a sample of people who haven't, all right? Now, you have to be careful about how you choose that sample, and we're going to get into that a little bit more later, all right? And so I'll just leave it at that. You want to be careful about how you choose the sample. It should be random. It should not be biased. All right. So let me give you another example. Let's say that the library, this is not true, by the way, but let's say that the library has proposed cutting their hours. let's just say, and you're trying to gather what is Merced College students' opinion on that. It would not be fair of you to stand in front of the library and ask the first 100 people who come into the library, how do you feel about the library proposing to cut their hours? All right, the library would say that's not fair the way that you're doing that survey, and they would be right. Okay, so you should include, because I would like to think that all Merced College students use the library, but that's probably not true. Maybe one semester you're not taking an English class or some other class that uses the library. And so maybe that semester you don't really care what the library's hours are. So, the people that feel that way, they should have a chance to get into the results of this. Okay. All right. So that's the kind of thing we're going to be talking about a little later. A census is where you literally ask every single person in the population. So I don't know about you, but when I hear the word census, I think of the US Census, where every 10 years, they literally ask every single person who lives in the country, every adult, I guess, to fill out a form with information about their family and this and that and the other thing. Okay. All right. So that's where you're asking everybody, but most of the time it's not practical to do that, and so we just go with samples. All right, so here's an example of what we're talking about. In the journal article, Residential Carbon Monoxide Detector Failure Rates in the United States, that sounds like fun reading. It was stated that there are 38 million carbon monoxide detectors installed in the United States. When 30 of them were randomly selected and tested, it was found that 12 of them failed to provide an alarm in hazardous carbon monoxide conditions. So that's kind of troubling, right? 12 out of the 30 did not do what they're supposed to do. Okay, so let's talk about what is the population in this scenario and what's the sample. The population would be all 38 million carbon monoxide detectors. Okay? So this is the perfect example where it is not practical or even possible to figure out how many of the 38 million carbon monoxide detectors work. I just can't do that. So instead, I pick a random sample of 30, and by the way, 30 is a very, very small sample. We could probably do better than 30, but it is an example of a sample. The sample would be the 30 carbon monoxide detectors that were selected and tested. So the objective is to use the sample data as a basis for making a conclusion about the population. Okay? And the bigger that you can make your sample, the better and the more sound your conclusion will be. Okay? All right, so this is very small writing. So for the people in the room, I am going to, especially, I'm going to try, whoops, I think I just printed my screen somewhere. Okay, well, this is probably about the best I can do. And I don't want to go through every word of this. This is just giving you more details about the prepare, analyze, conclude idea. So under prepare, you have things like what do the data represent? What are you trying to do? Do the data come from a good source? I see this kind of thing on social media argued all the time. Where did you get this data? And how did you collect your sample? So those are all important questions to ask when you're preparing your statistical study. Analyze, I mentioned before, is where you do your number crunching. You might want to make a graph and then exploring the data. Are there any outliers? So these would be really, atypical, unusual numbers. Think of a class where there was an exam that was really, really, really hard, the kind that where somebody asked, are you going to curve this? All right. Maybe the highest score anybody got was a 70, except for that one person, you know who they are, who got a 98, all right? So that 98 might be an outlier, okay? What kinds of statistics summarize the data? So we're going to be talking about the mean and the standard deviation a lot. The mean is the average, and you probably know what that means. The standard deviation, we're going to talk about that later. That is a measure of how spread out is the data. How are they distributed? And there are different terms you can use for that. Is there any data missing, et cetera, et cetera. And then under your conclusion, you know, what does this mean, basically? All right, and that's usually, I think, the hardest part. Analyze is the easy part, really. The part with the number crunching, all right? Figuring out how to pick a good sample and how to make your conclusion. Those are sort of, to me, I think, the hard parts. Okay. All right, so here's another example. This is kind of a sad example. Pleasure boats and manatee fatalities from boat encounters. Okay, so we will not spend a lot of time on this example because it's kind of depressing. But this is just showing you an example of where you might want to see if there is a relationship between two sets of data. So that, you know, one idea is that the more pleasure boats they're out, the more likely it is that, you know, the sea creatures might get hurt from the boats, right? So this table includes the number of registered pleasure boats in Florida in tens of thousands, and the number of manatee fatalities from encounters with boats in Florida for each of several recent years. And so my guess, if somebody was asking me, well, what do you think we're going to do with this? I would guess that we're going to see, is there a relationship between the number of pleasure boats and the number of fatalities, all right? So my guess would be that the more boats there are, the more fatalities there are, okay? Whether or not that's true, we're not trying to do that now. Maybe we'll come back to this example later when we're ready to do that. I kind of hope not, but you know, maybe there'll be a, you know, kind of more uplifting example. And these data are from the Florida Department of Highway Safety and Motor Vehicles and the Florida Marine Research Institute. So that seems to be a good source for where to get this data. I didn't just get it off Reddit or 4chan or something like that. And the data were obtained from official government records that are known to be reliable. So that's, it seems like we've got all our ducks in a row when it comes to sampling. Okay, so now we get into different sorts of things that can go wrong with sampling. So one way to collect a bad sample is to do what's called a voluntary response sample. This is one where the respondents themselves decide whether to be included. Think internet polls, all right? Don't try to draw any sort of meaningful or reliable conclusion from an internet poll, all right? Another example of a voluntary response situation, have you ever heard of a website called Rate My Professor? Voluntary response. The people who are really mad and sometimes the people that are really happy are the people that you see writing stuff on Rate My Professor. Usually the people that are just, you know, feel kind of neutral about it, usually they don't bother, okay? So here are some more types of polls that are common examples of voluntary response samples. So you should take these with a big, big grain of salt. Internet polls. Mail-in polls where people can decide whether to reply. And I can't remember the last time I saw one of these. No, I have actually. Telephone call-in polls in which newspaper, radio, or television announcements ask that you voluntarily call a special number to register your opinion. I don't know if you've ever noticed there's a channel on cable TV called C-SPAN. That's the one that covers government. And every morning, I think it comes on too early in the morning in California because it's broadcast from the East. And every morning they have a show where people call in to give political opinions. So again, these are people, not people that feel neutral about political stuff. So don't try to draw any conclusions from what the callers to C-SPAN are saying. Okay, So here's an example of something. Nightline, which is a TV show, asked viewers to call with their opinion about whether the UN headquarters should remain in the United States. Viewers then decided themselves whether to call in with their opinions, and 67% of respondents said the UN should be moved out of the United States. Well, compare that with this separate independent survey where 500 respondents were randomly selected and surveyed, and only 38% of them said the same thing, that they wanted the UN to move out of the United States. On the one hand, you might think, well, 186,000 people, that's a lot of people. You know, it's a lot more than 500. Well, guess what? The second one is a better indication of how people actually feel, okay? Because the people did not get to self-select, okay? So, which I think is what this says. Yeah, the smaller poll of 500 respondents is more likely to provide better results because the sampling method was better. Okay? Not voluntary response. Okay, and that brings us to analyzing. After completing our preparation by considering context, source, and sampling method, we begin to analyze the data. So one way to do that is by graphing. And then applying statistical methods. A good statistical analysis, this might be good news to some of you, does not require strong computational skills. I mentioned to you before, in a perfect world, I would love someday to teach a statistics class where everybody has either a graphing calculator or a laptop with Excel on it, and we don't have to do any number crunching by hand. We can just feed it into the computer and spend all the time talking about these other things like how to collect a good sample and how to make a conclusion, because those are really the important things. Okay. And then the final step, conclusion. We should develop an ability to distinguish between statistical significance and practical significance. So statistical significance is achieved, and I remember it's been quite a long time since I've taught out of this particular book. But one thing I remember he does is he has a really good simple definition of statistical significance. That means that the likelihood of an event occurring by chance is 5% or less. Okay. So a couple of examples: getting 98 girls in 100 random births, that would be statistically significant because that is really, really, really unlikely to happen by chance. Okay, 98 out of 100. 52 out of 100, that could easily happen by chance. That would not be considered statistically significant. Okay. You know, for example, there are all these old wives' tales about, you know, if you're trying to have a child, you know, making it more likely that you'll have a boy or that you'll have a girl. All right. So this, you know, we might be studying whether any of those actually work. And as far as I know, they don't. So practical significance: it is possible that some treatment or finding is effective, but common sense might suggest that the treatment or finding does not make enough of a difference to justify its use. So here comes an example of that. Perfect. Exactly what we were just talking about. ProCare Industries once supplied a product named Gender Choice that supposedly increased the chance of a couple having a baby with the gender that they desired. In the absence of any evidence of its effectiveness, the product was banned by the FDA as a gross deception of the consumer. So suppose this product was tested with 10,000 couples who wanted to have baby girls, and the results consist of 5,200 baby girls born in 10,000 births. That would be a statistically significant result because the chance of that happening is only about 0.003%. Okay. However, the 52 this result does not have practical significance, because if you really, really want to have a girl, this product could just claim that they make the likelihood that you'll have a girl 52%. And that's not that far off from 50%. Okay. And then they include this little tidbit that I didn't know. In reality, the likelihood of a baby being born a girl is only about 48.8%. I didn't know that. Okay, some things that can go wrong when it comes to analyzing data, reaching misleading conclusions, reporting sample data instead of measuring it. Oh, so if you're, for example, trying to do a study of how tall people are, you should actually measure their heights yourself and not ask them, how tall are you, right? An even better example of that would be weight. Right? Don't ask people how much they weigh. If you really, really need to know that, then weigh them. All right, and hopefully they won't hit you. Loaded questions. All right, and this, a lot of this is beyond what we're going to do in an elementary statistics class. If any of you are going into social sciences, maybe some of you want to be, you know, like psychologists or something. You will take probably a class called research methods. And in a class like that, you talk a lot more about how do you write a good survey question. Okay. Even the order of questions can be important. Okay. Non-response, you need to account for that. Sometimes people don't want to answer. For example, you ask them how much they weigh. Okay. All right, and then be careful about percentages. Some studies cite misleading percentages. Note that 100% of some quantity is all of it, but if there are references made to percentages that exceed 100%, such references are often not justified. Notice it says often. There are times when percentages over 100% do make sense. I could say that, you know, I made some change in my teaching that increased my success rates by 400%. That is absolutely possible. Something increasing 400% means that, you know, if let's say 10 people passed my class before I started doing this, and 50 of them passed after I start doing it, that is an increase of 400%. It went up by 40 people. 40 out of 10 people is 400%. Okay. It does not make sense, though, for something to decrease 400%. That doesn't make sense. And it doesn't make sense to talk about having 400% of something. All right. All right. And that is the end of section 1.1.